When we deal with large problems, the first step is to run correlation analysis and remove variables that are causing multicollinearity problem. Once we have completed that, then we can perform variable selection analysis, and there are 4 different ways in which this can be done. The first one I want to discuss is best subsets regression. So here we're trying to determine the best regression of each and every size. For example, if you have like 5 different x variables that you're considering, you want to look at the best regression model with just one variable, best regression with 2 x's, best regression with 3 x's, and so on. So how do you develop this? So in step 1, you run all regressions with just one x variable taken at a time, and then select the best one. And then you run all regressions with 2 independent variables taken from the list of x's that you have, 2 at a time. And so if you have 5 variables, you want to take 2 x's at a time, there will be 10 different models. And you run all of the 10 and select the best R squared from that. And then you look at 3 variables at a time. Run all possible 3 variable regressions and select the one with the best R squared. And you keep going like that until you get to the full model. So at each number of x's level, you will have the best possible model. So this is the best subsets regression. Now this, depending upon how many variables you have, this can be very time consuming. If you have 10 variables, you'll end up spending a lot of computer time and may not be worth it. So there must be a more efficient way of finding the best model, and there are 3 ways in which we can do this. And the first one is called forward selection. Now this does not guarantee the best model at each size, like the best subsets regression, but then it is pretty good. So here you run all regressions with one independent variable and select the best one. So the step 1 is same as in the case of best subsets regression. But then in step 2, you don't consider all possible 2 variable combinations, but you only look at the first variable that you've selected in step 1, you keep that, and then from the remaining x variables, you pair with the one that you've already selected each of the remaining x variables and select the best model from that. So now you will have the 2 variable model. Then you repeat this, and now with the 2 variables that you've already selected, consider adding one more from the remaining variables, and consider all of them and select the one that gives you the best R squared. In fact, what we will be using is what is called alpha to enter. So when you're trying each of the remaining variables with the already existing, the variables that have already been selected, you look at a p-value for the individual significance of the variable you're considering. And you will have an alpha to enter, like 5%, 10%, whatever. Then if the p-value is less than that, then only you will enter it. If the p-value is greater than the alpha to enter, you will not. You'll stop at that point. If you don't have any variable that has a smaller p-value than alpha to enter, then you'll stop. Now if you want to make sure that you'll have a model at every size, including all of the x's taken into the model, then you have to use 1 or 100% for alpha to enter. In that case, each and every variable will get included at one point or another. So that is forward selection. Next is backward elimination. Here it is about the same as forward selection in reverse. So you start with all the independent variables included, and then you compute the significance, individual significance p-value for each of the variables in the model, and the one that has the largest p-value, you throw it out, and then keep repeating that process as long as the largest p-value is greater than the alpha to remove. Okay. Once you reach a point when all the p-values are smaller than the alpha to remove, then that's it, you stop there. Now if you want to have models of all the sizes, then you should use alpha to enter of 0, then each and every model size will be included in the backward elimination. Now the third one is called stepwise, which combines both the forward and the backward elimination. You start as a forward selection, which you consider all the variables one at a time. So you include the first variable in, and then from the remaining variables you compute the p-value of individual significance and add the best p-value into the model. So now you have the second variable in. So when you add a variable into the equation, you immediately test to see whether any of the existing variables should be removed from the equation. So you perform a backward elimination step. So you do step 2 and step 3 repeatedly. Okay. If you have a p, and you will have p-value to enter, so the best p-value, if it is less than the p-value to enter, you will bring in the variable, and then from the variables that are already in the model, you will compute individual p-value significance and select the largest one, and if that largest one exceeds the alpha to remove, then you will remove that. So you keep doing this until you are not able to add any variable and you are not able to remove any variable. At that point you will stop, and that will give you the best possible model using stepwise regression. So we're going to look at the same example that we saw in the correlation case. So total sales with 8 different x's, and remember the time variable we have already removed because of multicollinearity problem. So we will use the remaining independent variable with y and run the forward selection, backward elimination and stepwise using Excel in the next video.